Welcome to the third part of the lesson 4.4 tutorial, where we are just going to finish up example 4 and then do how to put radicals in order from smallest to biggest, and then look at a word problem. So in example 4D, we have the fourth root of 80, and we want to write this in a simpler form, which will be its mixed radical form. So we're going to go and look for, do the factor tree for 80 and break it down into its prime factors and write 80 as the fourth root of its prime factors. So we see that its prime factors are 2 times 2 times 2 times 2 times 5. Because we have the fourth root, we are looking for equal groups of 4 factors being multiplied together, because that's a power of 4. So we have 4 2's. So we're going to write that as the fourth root of 2 to the power of 4 times 5. And then break apart our roots. So we got the fourth root of 2 to the power of 4 times the fourth root of 5. And the fourth root of 2 to the power of 4 just equals 2, because the fourth root and the exponent of 4 cancel each other out, and then times by the fourth root of 5. And that is the simplest mixed form of the fourth root of 80. Similarly, we're going to look at the cubed root of 60, and we'll make a factor tree for 60. So here I've made a couple factor trees. They're a little different, but they still give us the same result. It just depends how you break apart the 60. And we see that we have the prime factors of 2 times 2 times 3 times 5. So we can go ahead and write the cubed root of 60 as the cubed root of the product of the prime numbers, so 2 times 2 times 3 times 5. And because we have the cubed root, we're looking for equal groups of 3 factors, and we only have 2 2's and then one of the other numbers, so we don't have a perfect cube or 3 equal factors. So in fact, the cubed root of 60 is in simplest form already. So cubed root of 60 is just its simplest form, even in mixed form. So because there's not an equal group of 3 factors. If we were taking the square root of 60, we would have an equal group of 2, which we would be able to simplify a little bit if it was the square root, but it's just the cubed root. Now let's look at ordering rational numbers. There are 2 ways that you can compare radicals to put them in order from smallest to largest or largest to smallest, whichever you need. And the first way is to convert all your radicals to entire radicals, and then you can compare the radicands. All radicals must have the same index for this method. Smaller radicands are smaller numbers. The second method is to use a calculator to convert all radicals to their equivalent decimal numbers, and then compare the decimal numbers and put them in order. For example 5, we're going to put these 4 radicals in order from least to greatest using both methods previously discussed. In method 1, we need to convert all of the mixed radicals to entire radicals. Then we can compare the radicands. So we need to convert 3 root 2 and 2 root 18 into entire radicals. So if we do 3 root 2 first, we have to write 3 as an equivalent square root. So it's the square root of 3 squared times the square root of 2. The square root of 3 squared just equals 9. 3 squared equals 9, so we have 9 times 2 under the root sign, and that gives us a square root of 18. For 2 times the square root of 18, we have the square root of 2 squared as an equivalent root there, and it's going to be multiplied by the square root of 18. So that's going to be equal to 2 squared, which is 4, and times 18. And 4 times 18 is just equal to 72. So we'll have the square root of 72. Now the other 2 radicals were already entire radicals. So we had the square root of 32 and the square root of 8. Now, because we have all of the same roots, they're all square roots, smaller radicands mean smaller numbers. So square root of 8 is the first number in our order from least to greatest. Then we have the square root of 18, Then we'll have the square root of 32, and lastly the square root of 72. And if we're writing them in order from the original numbers, the square root of 8 was just the square root of 8. The square root of 18 was originally the 3 times the square root of 2. Those are equivalent. And the square root of 32 was just square root of 32. And the square root of 72 was simplified or changed to an entire radical from 2 root 18. So that is our order from least to greatest. If we do that using method 2, we need to convert all of our radicals to decimal numbers. So if you type in your calculator the square root of 32, you get 5.656 ... because it keeps going. And then we have 3 times the square root of 2. So you type in 3 times and then the square root of 2 and you get 4.242. If you type in the square root of 2, or 2 times the square root of 18, you will get 8.485 ... And lastly, the square root of 8 would be equal to 2.828 ... So now the smallest number out of all these decimal numbers is 2.828, so the square root of 8 was our smallest radical. And then the next smallest was 4.242, so we have 3 times the square root of 2. Then 5.656, so the square root of 32. And lastly, 8.48 was actually the biggest, so it goes at the end, 2 root 18. And that's our order from least to greatest, which is the same as above from method 1. Finally, let's look at a word problem that involves irrational numbers. In 2007, a gold mine in Saskatchewan produced a daily average of gold great enough to fill a cube with a volume of 360 centimeters cubed. If 5 days of gold production is cast into a cube, what is its edge length? So we're trying to find, for a cube, its side length, which, because it's a cube, its length, its width, and its height, they're all just s. They're all the same. The information that the question gives us is the volume for 1 day, which was 360 centimeters cubed. So that was for 1 day. We want to know for 5 days of gold, what's the cube's side length. So we'll take the volume for 1 day, and multiply it by 5 to get our volume for 5 days, which is 1,800 centimeters cubed. So that was for 5 days. So now, if we look at the volume formula for a cube, the volume of a cube is equal to the side length of the cube cubed. Length times width times height gives us volume, so because they're all s's, it's just s times s times s, which is s cubed. Now we know the volume, so we'll sub that in. 1800 is equal to s cubed. To undo the cubed on the s, because we're trying to get s by itself, we can cube root both sides of the equation. That will cancel out the cubed on the right side, so we'll be left with s, and I'll write s equals. And then the cubed root of 1800 is equal to 12.1644 ... And because it's now just a side length, we have just centimeters as our units. So the side length of the cube is going to be approximately 12.2 centimeters long for 5 days worth of gold. That concludes the tutorial videos for lesson 4.4. Now you can go and try some of the practice problems.